Okay. So let me go once again. So we have the control layer or control tier, we can say the control layer that is accepting the request. So this control layer or user controller is uh, acting as a REST API. So REST API is one of the methods that we can interact from the user side. Okay, this is one of the methods. So there are other methods where user can interact. As I mentioned earlier, there are like new versions coming in, new things, new technologies coming in. So for example, there are technologies like GraphQL. Okay, so if you want to implement something in GraphQL, yes, you can totally do that. Okay, rather than using a REST API, we can change our interaction type to GraphQL. There are new things like RPC, TRPC, gRPC. There are like gRPC is not directly available from the client, but there are ways that we can interact. Okay, the clients can interact with our service. So this one happens to be a REST API, and the REST API function, the functionality of this REST API is to accept whatever the values that is coming, and after accepting that, the logic behind it, whatever the logics that we need to do, it's going to be behind the service layer, okay, or service tier. So we have the service tier in here, and the service tier is responsible for doing the logical stuff, and make sure that when we are doing such things, okay, when we are doing such applications, or when we are creating such application, the logical layer, the application, the service layer that we are seeing in here, uh, is an independent layer, independent tier that does not care about the interaction layer. That means it does not need to know about how these values are getting, whether it is a REST API, GraphQL, DHCP, whatever the communication mechanism it is coming from. Its purpose is to do the business logic when they got the correct input, and it will give the correct output. Okay, so the input and output is this layer's interaction. It does not care where the information is coming from, what type of mechanism they are receiving, as long as they receive the intended value, and the business logic, as long as the business logic is executed, they do not worry about the business logic that we are having. Okay, and what I'll do is I'll demonstrate why this kind of information, why this kind of application is really important when it is coming to testing the application. Okay, so how many of you guys know about testing? Okay, I'm talking about not the testing that we do physically or like by human interaction, but as a good programmer, you guys we should write test for your applications. So how many of you guys know about different kind of testing, such as unit testing, integration testing, end-to-end testing? Raise your hand if you know anything about testing methodologies. Okay. 042, can you explain what you understand by testing? 042. Hello? 042, can you hear me? Okay. Can you explain what you understand by testing in programming? Can you speak up?
Testing the program work correct or not.
Uh-huh. What sort of things that you're going to be testing? I mean, the program, yes, when we are talking about testing, we are talking about the correct behavior, but there are different type of tests that we need to conduct based on the logic, based on the place. Do you know what are those things?
Unit testing, integration testing.
Yeah. So in here we have a simple line of code from code 9 to code line 12. So what sort of testing that you will prefer to make sure the create method is working as expected? What is your approach on that?
Unit testing.
Okay, yeah, correct. So since this is a single method, okay, the single method is to be tested using a unit test. Okay, so unit test basically involving testing out a class, something like this, or a method. Okay, so we will be testing something out of the source code, whether this method is working as expected. Okay, so why do we do such a thing? Say for example, somebody from another team, or somebody who is new to joining, they might come and change this source code due to a business logic. Okay, they do some changes, they can add some things, they can remove certain things. But the problem is, when they do that, uh, how do we know we are not breaking the existing system? Okay, how do we know we are not breaking the existing system, or we are not doing something that is illegal, or how do we know that it is misbehaving? Okay, so the person, they might have an idea, but if they do not have an idea, the only safeguard that we can do is write a test case against this method. Okay, so the basic idea on this method is to get input of a user. This type, the type is user entity, and the variable is user. Okay, once we got this, what this program does, or what this method does is, the user.id field will be populated with an id underscore current date, but not the date, but it's the millisecond of the current date. Okay, so it will be populated with the date that we are having. And the next thing is, it will be pushed to this what do you call, the array, and this method will return the user back. Okay, so there are three things happening within this application. Three lines of code do three different things. Okay, so if somebody comes and do do a change in here, some sort of unwanted behavior, then what we need to do is we need to check whether that is acceptable or not. For example, let's assume that the ID, okay, the user ID, it is always starting with ID underscore. Okay, and somebody comes here and he was doing some changes, and accidentally he have deleted the underscore. Okay, so there was underscore in here, and accidentally he or she have, the developer have deleted the underscore. The program will work, right? The program will work because the underscore is it is a part of the string, is part of the value, um, but for our business requirement, we need the ID to identify or to some business logic. We need the underscore in here in this place. So what will happen? The new guy or the person accidentally delete this code or purposely delete this code. Then what will happen is our system is not working as expected. We do not know what sort of change we have done, and due to that reason, the system is not working as expected. So how we can make sure any changes that the person has done is not affecting the system? How we gonna make sure that any changes will not break any existing capabilities? Okay, of course there is the element of unseen, or there is the element of not knowing errors. Okay, there are some errors we can't anticipate. We do not expect to write all the use cases, all the information that we are supposed to have within this method. Okay, there are some unforeseen use cases. So those things we can, we can't do that. We can't write test cases for all the use cases that we are having. But the known cases, the known behaviors, at least those behaviors should covered up by using the testing that we are doing. Okay, so do not think testing is something for QAs or QA people to do. Okay, QA engineers, their job is to test. No, testing is like the main behavior or main job, as far as I can see, within a software engineer. That is without a doubt. Okay, writing code, yes, you can do. Anyone with capable of typing, they can come here and type anything and it will work. But maintaining a code, writing a reliable code, that is a part of what we call engineering. Okay, so programming and engineering are two different things. So part of engineering assessment, or part of the engineering task that we do, testing is something should be included. Okay, so people might say, okay, testing is not relevant, our deadline is to type, we can't do testing and everything. There are use cases, of course. Even myself, I had to skip testing, not because I liked it, but certain clients, they do not need, they ask not to waste time on testing. They don't have budget. But believe me, each and every time I skip writing testing, what happened was it come back and bite us again. The reason is unexpected behavior is happening here and there. We can't predict the outcome. Okay, one single change by done one person is affecting somewhere else in the system. The system is sometimes unreliable. Okay, so to make sure the testing works perfectly, we need to have testing in here. So in the NT architecture, why do we need test? Okay, why do we need test in this scenario? So we will see what is the purpose of writing test, and what we can get from writing test. Okay, all right. Okay, we will write test and see how we can secure this, and by clearing up the things, what is the benefit? What is the benefit of writing a test? Okay, so we will write a test for this create method, and we will see by writing a test case, how we can um, keep our code very clean. Okay, so to write test cases, it depending on the framework that you are using. It can be JavaScript or Java, .NET, whatever the um, whatever the framework that you are writing. Testing is something that happens within the same code, or sometimes within a separate section. But for the use case of web-based application, we'll be writing the test as same as the layer we are having with the service. Okay, so we have the user.service. What we will do is we will create another file called user service.spec.ts. Okay, most of the time this is identifiable by this spec definition. Okay, so anything related to test is ending with spec.ts. That's indication of, okay, this is going to be a test file. You guys can see the icons. If you're using something like VS Code, they have different icon colors, so we can differentiate the test and the real code. So right now I am going to write a test case for this create function. Okay, this create function, and we will ensure the the function will not break if you do any changes. Okay, so when we create a spec file, you guys can see that by default there are like some test cases written for us. So we will get the inspiration from here. Okay, so first thing that we need to do, we need to group the test cases. Okay, so we have in here, you guys can see we have several services in here. We have right now we are having the user service. Within this user service, there can be even within the same file we can have multiple services, but that is not the what do you call the best practice, but we can. Okay, so we need to organize our test cases. So right now what we're going to do is we have we have a class called user service. We'll be writing we'll be writing test cases against this user service. All right, so what I'm going to do is I'm going to come to my spec file, and I will use a method called describe. Okay, within the describe block, okay, within the first parameter for the describe, what I will give is the name for my test case. Okay, so think describe as a way of organizing my test cases, and I am organizing my test cases for user service. Okay, and the second parameter is accepting the actual test cases that we're going to be writing. Okay, and right now I do not have any test cases, so that's why the red error comes from. Okay, so right now I'll be I'll be uh, I'll be uh, I'll be testing user service, and within this curly braces, within this body, I'll be testing the whole functionalities between the user service. Okay, and you can have the name anything you like user service testings. Okay, this is like a name that will help us to uh, identify what sort of testing that we're going to be doing. Okay, all right. Okay, now the next thing is we need to make sure there are things what we call testing life cycle methods. Okay, so when we start a test case, we call these things like test suites. Okay, when we start a test suite, what will happen is um, the test suite have different life cycles, like everyone in here, like people that we are. Life cycle of test suite uh, is gonna be there. So there are like 4 identifiable life cycle events that happen within a test suite. Okay, within this test suite, there are 4 different life cycle methods. First one is before all, before, the second one is before each, and after each, and after all. After all. So these are like the primary testing life cycle methods. Okay, these are the primary testing life cycle methods. So as I mentioned, the describe block gives us a test suite. That means our tests are going to be within this code section. So within this test suite, we can have many test cases. Okay, we can have many test cases. For example, I will show you. I will show you guys one simple test case. The test case always start with something called it. Okay, and we normally have a name for the test case. All right, so that way we know the test case is running. Okay, the test case is having a name, like the test suite describes, give the test suite name, and the individual test that we are supposed to perform have a name as well. So I will give the name. I will give a name, but for reading and maintaining purposes, most of the time we give the naming convention. We have a naming convention like uh, the test case. What is the expected behavior of this test case? Okay, so it is like a confirmation thing that we do. So we always start with should. Okay, so if you guys try to read this, it should. Okay, that means we are assuring that the code should do this, should do that. Okay, for example, uh, it should create a service instance. That means this is the method, this is the name that we give for the test case, and the behavior we are expressing something like this. It should create a service instance. Okay, and we can have something like it should create a user. Okay, it should create a user. uh, we can be more descriptive when we call post method. Okay, so we can have a testing name something like this: should create a user when we create the post method. But in here we have a create method, so I will use that same name. So it should create a user when we call create method. Okay, the next thing that we can do, it should have more than one user in array when we create a user. Okay, so we can see what we are trying to test. So it should have more than one user in the array when we create a user. You guys can see within the service, if you create a user, the array should have more than one user. Okay, so that means we are testing something. So likewise, we can say if we delete the user, okay, if we delete the user by an ID, it should reduce a user from the database. Okay, that means it should remove remove a user, and the count will be less than 1. We should have remove yeah, let's give it a good name. It should remove a user, and array count will be dropped by 1. So you guys can see we are giving the test cases. The first one is it should create a service instance. That means without an error, the service instance should be created. And the next thing that we are expecting, accepting, it should create a user when we call the create method. When we call the create method, okay, see that I caught it in here. Where it should create a user, that means without an error, we should be able to create a user when we call the create method. So when we create a user, the array should have more than 1. Okay, more than 1 or more than 2, whatever the number that we are coming first. It should not be empty. So you can say it should uh, uh, it should uh, it should not be empty array when user is created. Okay, so you can be creative and make sure you give a definite meaning to the testing that we're going to do. So I have given it should create a service instance, it should have a create method, it should not be empty. When you remove, what should happen? So likewise, we can write test cases. Okay, we call these things test cases. Okay, so we haven't done what is the testing method exactly, how we're going to test it. At least we have defined how it should, what is the thing that we're going to be testing. Okay, so within this test suite, we have defined 4 different test cases, and within these test cases, what should happen, we will decide on the testing body. Right now, they are not having a body; they're just laying there. Okay, so what is the what is the what do you call it? What is the relationship between the testing lifecycle methods and test methods? Okay, the life cycle methods executes in different stage of this test suite. Okay, so there is a lifecycle method called before all. Okay, the before all method is executed. The method is executed before all of these tests are executed within the test suite. Okay, before all of these tests are executed, we run the before all lifecycle method. So how are you going to do that? There is a method called before all, and we can say what should happen before all of these uh, before all of these test cases are executed. So I can say console log, I will say just before all life cycle method. Okay, so remember, when this test suite started to execute, before all any of these tests are executed. Okay, the test suite have like 4 test cases right now. Before any of these things are executed, the before all function get executed. Okay, and there is the other function before each. Okay, so before each function, before each life cycle method, or we can say, is also a life cycle method. Can you guess what it does by the name given before each? Anyone have any clues? When this method will be executed? So before all will execute, the before all method will be executed in before any of these test cases are executed. What do you understand by before each then? When the before each will be executed? The before each lifecycle method will be executed before any of these will execute. So before the first one execute, the before each will be execute. Before the next one is execute, let's call this one test 2. Before the second test execute, before each again executed. Before the third execution happens, before each this one will be executed, and even before with the last execution, before each is executed. So if you have 100 test cases, before each of these tests are executed, the before each method will be executed. So I can say console log before each should be life cycle method, before each life cycle method. Okay, so you guys can see before all executed, uh, right before any of these things are executed, before each is executed, each and every one going to be executed, but any of these get executed, before any of these gets executed, it will be the before each will be executed. So you guys can see the next thing, after each. Okay, so any guesses what after each does? Anyone have a theory? When this will be executed after each? And after all. So what, just look at the name itself. Okay, name itself, it implies after each. That means this method will be executed after each of these test execution. Correct? One of you got the answer. So this one execute, the after each method is executed once again. This one execute, after each executed once again. And you guys get the idea. Okay, then after all of these are executed, after all of these test cases are executed, the after all method is executed. Okay, so that is the life cycle methods. Let's see how these things works in real action. So I can run this all test cases just simply clicking on the run button over here. So if you guys do not see this run button in VS Code, all you have to do is install plugin called Jest Runner. Then you will get the running section over here. Probably you will get this one out of the box otherwise. If you don't see, just have the extension installed. Okay, so if I click run on here, what will happen is it will run the test suite itself. All the test suite related stuff will be executed in here. And anything within the code will be executed afterwards. Okay, let's run it and see the output. the missing argument or a callback action. Okay, so basically this is not gonna run because we should have a method implementation in here. Okay, so that is the error. So I'll have a method in here. So within this test, what we are gonna test, it's gonna be in here. So I'm gonna simply console log in here. So we are not simply, we are simply just printing out test one right now, and we will write the original test again once we are done. Test three and test four. Okay, so this is not the actual testing mechanism, but for demonstration purpose for right now, we'll just have something console log in here. Okay, now we'll try to run the test suite once again, and you guys can see there are certain outputs coming in here. So you guys can see before all lifecycle method is executed, then you can see before each lifecycle method is executed and test one is executed. Okay. Next thing, after each lifecycle method is executed. That is correct because after each will be executed. And again, what will happen before the second test can execute, before each lifecycle method is executed, then the lifecycle method is executed. After the lifecycle method, after each lifecycle method is executed. Before the third one executes, before each executed, and after each executed afterwards, before the test for, before each function is executed, and after each lifecycle method executed. Since there are no more test cases to be run, after all, I think this one should be after all. I think I have, yes, this one should be after all. Let me run it again. So after all the life cycle, after all the tests are running, after each for test 4 is executed, and after all life cycle method has been executed. Okay, so we had four test cases, and during this test case, during this test suite, we have executed these life cycle methods one by one. Okay, after all, sorry, before all, before each, after all. Okay, these are the life cycle methods which will be executed based on the number of test cases that we have. Okay, so let's see why these life cycle method exist. What is the purpose of these, each of these life cycle method? And given the given the given the uh, even there are like 4 life cycle methods, what we are trying to achieve from these life cycle methods. So the first thing is, before all, this kind of the place that we can create our resource gathering. Okay, say for example, we want to have some sort of connection to our database. Okay, we need to connect to our database in order to make the service work. This service, the user service, is depending on a database connection. Okay, so we will not get connection per per test case. We will get a test connection for the whole test suite. While we are running the test suite, we will have one single test connection, because creating a test connection is resource consuming. Okay, we can't have, if we have 1,000 test cases, we can't have 1,000 database connections. That is not allowed most of the time. So we can't have that. So for the test suite, all test suite, we might need one database connection. Okay, so any resource allocation can be done in before all method. Okay, Say for the example is the database initialization that happens in here. So we have the counterpart of before all is the after all. Okay, so after all method is basically releasing anything that is done in the initialization part, or we call the test suite cleanup. So once and every test case is executed, we might need to let go the database connection. We need to clear some cache. We need to free up some memory. So anything related to this test suite, the describe block that we're having, we want to release these things. So what we do is we can do it in after all. Okay, after everything is done with testing, we will release the database, we'll release the cache, and if you want to clean up something, we will do it from here. Okay, and we have the before each method. Okay, before each method is somewhat what we call test by test clearance lifecycle method. For example, let's say the when we write unit test, okay, when we write unit test, each of testing that we do to our sorry, when we do testing, okay, say for instance, I am writing a test for the create method. I also need to write a method for, I need also to write a testing for get all method and delete method as well. So when we are doing unit test, okay, when we are doing unit test, we do not want to have interaction between the other unit test cases. So then hence the name, even the name suggests unit test. Okay, it is testing only a small unit of your code. Okay, so when we do unit testing, we do not want other test case execution to interact with or have an influence on other test cases. So for example, if I create a user, and once the user is created, I do not need anything to happen when I write get all users. So if I do a create, if I run a unit test against this method should be totally independent from the steps that we have done in here. Okay, so that is the purpose of unit testing. The independency should be there. Okay, so that's kind of thing should be happening when we are creating unit tests. So say for example, I create a service. Yes, I can create a service, and once I create the service, what should happen? This create method will put instance in the user DB in this array. So when I run a get all method, it is also using the same user DB instance or the array that we are using in here. So any test that we are running against the get all method might be polluted before, or might get interfered with the unit test that we have written for the create method. Okay, so that we do not want to happen. We do not want to. We do not want that to be happen. So when we are executing the create method, we should clear up the things that we have done. We have to clear up our mess. Okay. So in a typical application, we probably will do that in before each of these application, we will clear up the things. Okay. You can do it in after each, that's up to the user, but most of the time before each method is used to clear up any uh, existing cache or something like that. Okay, and after each you can use the same way, but it's up to the user to use the before each or after each. Sometimes they have different purposes. It's depending on the user, but we're going to be using on, which method that we're going to be using on. So we have the life cycle methods. Now let's see these things in action. Let's test these things out for real. Okay. So before all the tests that we're going to be writing, we should initiate the service. So we will be testing out things out from the user service. Okay, we will be testing out things from the user service. In order to test things within the user service, we should have a user service. Okay, we should have an instance of this user service. Otherwise, we can't test. Okay, so we will get instance of the user service. So how are we going to do that? Simple. We will call normally. We will have a service like this, and I will explain one by one. User service. Okay, so what we have done in here is simple initialization. So you guys can remember the before all method that we had. So we need to create instance of the user service. This is the one that we're going to be testing out, and we need to have a instance in order to test. So how we going to do that? We will be using something out of Nest.js itself. Nest.js has a package for testing as well. So we use the test class, which is available on the Nest itself. And we should, as you guys can remember, as you guys can remember, in Nest.js, a service should be registered on the use service should be registered on a module, right? You guys can see the user module is having the user service. So in order to test this service, we need to create a module first. Okay, but we can't create the module itself. Yeah, if we are creating a module, then we have to create the whole user module. So it's going to take us a little bit of time. So what we will do is, rather than creating the user module itself, we will create a simple testing module, okay, which is coming from the test package or test class we are having from Nest.js. It has a method called create a testing module. And by creating this module, what we'll do is, and you guys can you can see that we are giving, as we have given in the providers section in user module, we are giving the providers for the user service for this create testing module. Okay, so once this is done, there is a method called compile, and it will give us a dummy module. In this says a dummy application for us. Okay, we have a dummy application or dummy testing module for us. So once we have created this, we can get the hold of created user service by calling this app.get, and what is the method, what is the service that we are interested in. Okay, so simply this is the syntax of it. It might be different from one framework to another, but simply we are creating a service out of these testing modules. Okay, so we call these things like this is actually a real implementation, but we will see something like mocking and everything later on. So right now we are creating a test module which is resemble the user module, but it is not the user module, because if you are to use the user module, we have to have the user controller, and if we have so many things, we have to have all those things. Right now we are creating just a simple testing module. Okay, within the testing module we get a testing module instance, and simply calling the get method and passing the service type, we will get a user service. So if this function executes perfectly, if these things is done correctly, where since we have executed this before all, we should have a instance of user service. Okay, we can check that in the it should have created instance method. Okay, so we will test that. So how we gonna test whether we have created a perfect instance? Okay. Okay, so how do we gonna test that? Really simple. We have something called testing helpers. Okay, so how we gonna test that? We can use the method called expect. Okay, expect what we gonna be expecting. We are expecting this. We are expecting service. Okay, we are expecting the service that we have created in here, which is the user service. User service. Okay, the service that we have created, we are expecting user service to be uh, truthy. Okay, so to be truthy in the sense we are expecting the service. If you call to be truthy, you can see when we do not care about what value, we have make suring that it is none of these value. So if it is false, zero, empty, null, or undefined, or none, everything else is true. Okay, so if we created a perfect service, this will be this shouldn't be null or undefined or anything like that. It should have a value. The service should have a value, and the value is going to be in the shape of user service. Okay, so if we have obtained a service instance in here, user service instance perfectly, we expect the service to be true. Okay, that is the first test case that we have written. So the expect help us to evaluate our test. Okay, we are evaluating our test. We are expecting the service to be truthy, and we can expect other things for different test cases. We can expect different things. For now, we are expecting the service to be truthy. That means the service creation is completed. If not, the test case should fail. Okay, right now I can run this exact test case by simply hovering over the run method, which is right about right above the method. If I hit run, and you guys can see other test other test cases are skipped, and the test cases where the instance is created is passing. Okay, that means our test case is passing. So for fun, what we will do is we will stop the initiation of the service. Okay, so the initiation happens before all is not happening. That means we are not creating the service instance. We are not creating an instance of service. So this is right now is null. It's creating a null value. Right now, if I try to run this, it should give me an error. Okay. So actually it's undefined. So we expect to be truthy, but we received an undefined. That means we we did not get the expected test result. From testing, what we do is we expect something to be something, but if we if we did not get that value, then we are getting an error. So we expect this one to be truthy, but we received an undefined section. This is a failing test. Okay, so we are receiving a failing test. That's because we haven't initiated it correctly. Since I have uncommented this line, the service is initiated correctly and it should work. Okay, so this is how we can think, or this is how we can assume our test cases are running as expected. Okay, so before all, in the sense we are we are we are initiating our user service, we are creating a user service that need to be tested before any of these test cases are executed. And after all these test cases are written, we might need to shut down this application. So in here the const is in here. So I can't actually do that. So what I'm going to do is I'm going to say uh, const app, and rather than this, so I have to let app, and app is having a type of testing module. Okay, so as I mentioned earlier, we are creating some instances. Okay, we are creating some uh, resources in order to test our user service. Okay, so in this scenario we are creating this app.testing module. Of course you can just let it go like we did have anything, but sometimes this is can be error. uh, there can be errors like out of memory. If we have created a lot of app instances and we did not destroy these things after we are done with that, it might get some errors. So the best practice is before all these things, we are creating a testing module. And after all these things are done, we need to destroy that. So we can say app dot, what it is say, close. Okay. So the close function is the thing called terminating the application or terminating this function. So before all of these things happen, we create an testing module. After everything is done, we are terminating the application. So we are doing a good thing. We are creating our resources. As soon as we are done with it, we are disposing it. Okay, that is the simple gist of it. Okay, so if I run this once again, I will run this test, complete test suite. You guys can see the lifecycle methods are executing right now. Okay, before these things are in here. Sorry, after each is not the place, after all is the place. Okay, after all, I will just close the application. This one ran luckily because we have only one thing in here, but if you had something else, that would be. So you get the idea. Before all, we have instantiated. After all, we have closed. Okay, so we are doing resource releases as we allocated it. We allocated in here. We are releasing it in here. Okay. All right. Any questions up until this? Anything you guys did not understand about before lifecycle methods or testing things? This is the time to ask because I'm gonna dive into test case writing. Okay, I'm gonna dive into test case writing. So we actually did one, but in thoroughly we will go. Any questions that you need to ask? Right now is the time. Raise your hand if you have any questions. Don't tell me afterwards, okay? I did not understand or something like that. Right now, if you have anything, just ask. Sorry. Okay, that's good. So I hope you guys got the idea. Right now, the first test case is passing. That is great. And the next thing is it should create a user when we call the create method. Okay, so we should be able to execute a single method and it should do something. All right. So we have the service instance. Okay, we have the service instance that we created the service instance and we have the reference to that. So we can just simply call service dot create. You guys can see it is allowing us to create a user. But in order to create a user, we need a user entity to be passed. Okay, we need to have a user entity. So I will create a user entity, and it will be in the shape of user entity. And what are the things that I need for an user entity? I need an email. Okay, so I will give an email. I will say test at example.com. And when I want to create a user, okay, when I want to create a user, what should happen? I need to provide a user entity. So I can provide something like this. So I created a dummy user entity and I have given it as the input. So when I call this method, what should I get? I should get a user from the method itself. You guys can see when I create the method, I should get a user entity in return. Okay, so I got a user from there. So when we create a user, so if I look at the method itself, I create a user. The thing that I do, rather than just or the business logic, the change that I do within the ID, within the entity itself, the thing that we're going to do is that I am adding an ID field. Okay, I am adding an ID field to my user entity that I am creating. Okay, when I'm creating thing and I am returning the ID back. Okay, so when I create the user entity that I am creating right now, it does not have an ID field. Okay, it is just sending an email and I pass this user entity to the service.create method, and as a return I get a user. Okay, so within the business logic, within the create method itself, it is assigning an ID for my user entity. Okay, it is assigning a user entity, right? And the thing that I can do, the thing that I can test is that, okay, to check whether the user is really created, to check the create method actually done its job, is one thing that I can do is check whether this ID field is having a value. Okay, because if I pass a user within this value, it is getting an ID field. We are populating the ID field. And from the test side, if I say, okay, the create method is giving an ID and it is working perfectly, I should check whether there is an ID or not. That is one method of testing the method is working. So I can say expect user.id to be uh, to be truly. Okay, we can say to be truly. That means we can expect the user ID to be truly. That means it should be defined. It should not have an empty value. Let's run this. Yes, should create a user when we call the create method. Okay, that means we are getting a user ID, and our test case is working as expected. For fun, what I'll do is the create method. For some reason, somebody comes in here and let's say he have commented out this. The ID is no longer assigned. Okay, let's see what will happen to the test case. You guys can see expect receive to be truthy, but receive undefined. Then we are getting an error. That means we are expecting user ID to be truthy, but for some reason, someone in our team or for some mistake, we have changed the logic. We have done some mistake, and the ID is no longer setting up. The ID is no longer working as expected. Then all of a sudden, the test case fails. The test case is failing. This test is failing. So we know, before we are going to give this to our customers, we run our test cases and we find out, okay, one test is failing. When we look at the test case, somebody have accidentally commented this out. Somebody have accidentally do something that they are not supposed to do. We get the error before we go into the uh, user before we go to the user, and the user will have some sort of the developer will some sort of fix. The developer should come up with some fix saying, okay, we have changed something and it is no longer working. We have come up with a solution for that. Think we did not write any test cases, and we for some reason the manual tester, the QA engineer also have not be able to the QA engineer also fail to get this done. Then what will happen? Our project or our application will be not working as expected. We will get bad reviews from the end user saying, okay, your create user is not function, is working. We are unable to do that. All the hassle can be really prevented if we have the test cases running, and the test cases figure out an error or runtime error, some logical error, even before we go to production, even before we go to use. So we can see that the test case is passing if we have that. Okay, let's say we can write another test case, something similar to this. Okay, we can create something similar to this. Okay, we will copy this one for simplicity. It should create a it should have the created it should start the ID. It should start the should have underscore ID. It should have ID underscore at the beginning of the ID field. Okay, so another test case is that we should say it should always have ID underscore. You guys can see every ID that we are having is starting with ID underscore. Okay, so we can write a test case for this. So by simply looking at truthy is not going to be enough, because it's going to be truthy because it is having a value. Okay, truthy will just say, okay, it is it is that value. The value is there. Now we are checking. Now we are checking whether whether the ID that the created one, it's not the truth that we are looking. It should start with ID underscore something else. So how we gonna test that? How we gonna test this thing in real life? How we gonna match this? So we can do two things. We can do in different ways. So the best way that we can think is to match a pattern. Okay, we can have a pattern matching that we can do on this. Okay, so if you guys know regex, I think probably you guys must have an idea. Okay, so if we need to start with something, we can have a regex like this. Okay, I'm not going to teach you guys regex in this scenario, but simply a regex would be something like this. Okay, so this basically says it should start with ID underscore. Okay, let's see whether this is working. Yes, it is. It is beginning with something like this. For some reason, let's assume that. So this is simply saying the user ID to match ID underscore. Okay, this is the requirement. This is simply saying the user ID that we got should match this pattern. This pattern should be matched. Okay, so another instance, somebody come here and let's say they have deleted this one by accident, or they have added an extra. They have deleted. Let's say they have deleted it, and they are trying to publish this change. But before publishing, we run test cases, and you guys can see the expected pattern is this, but what we got is something like this. So they are complaining, you have done something wrong, which will fail in the production, or which will go against the business logic that we are currently having. Correct that first. Okay, so we can go and see here. Okay, somebody accidentally delete that. Let's add that again and try to run it. Then you guys can see, okay, my test cases are running, no issues there. Okay, so we can get assurance that our code is working as expected. Okay, so there can be changes happening in the code, but again, we have the assurance of these changes will not be affected, or will not be affected business logic. For some reason, let's say we have put the underscore before and we are trying to run this, and what will happen? It will again say, hey, your test is no longer working because you have done something wrong. Make sure the expected behavior is there. If you are trying to get something working, make sure that one is also working as well. So if your test is failing, that means you have done something wrong. Okay, there are some occasions because of the business logic has changed. Okay, now the business logic is to say the ID underscore is no longer working. Yes, if we want to remove that and make sure this is the exact use case. Okay, this is the use case from now on. Then we need to match and replace the existing test cases to match that. Okay, if you change the logic, make sure it is valid one. Okay, that is a valid logic. Now the business logic also should change. That is also going to be business logic has changed. Corresponding test case should be changes as well. But There is like a case where it's happen not all the time, but sometimes business logic can change. In that scenario, update the relevant test cases as well. Okay, so we have written two test cases in here for the create method. Okay, written one test case in checking the ID, and the second one is whether we are having the ID starting with ID underscore. That is the second one, and the third one is okay. The third one is the use case of when the user is created, the array should not be empty. Okay, so what we're gonna do is we're gonna have a user, and we're gonna be having the user created user, because we need the reference of the user created. But the next thing is we expect service dot user db user db length. Okay, because when you have a value uh, to be greater than 0. So basically what we are saying, it should not be empty array when the user is created. So when we create a user, when right after when we create a user, what should happen is the service has a variable called user db, this one. It should not be empty. Okay, it should not be empty. That means the user db length, the value of that should be greater than, to be greater than 0. It should be greater than 0. Okay, let's run this, and you guys can see it is working. Okay, and we can say another thing, greater than 0, or something like to be 1. Okay, to be 1, that means the length should be 1. Okay, let's run it. Yes, it is working. It should not be empty because it is 1. But interesting things can happen if you do not do the service correctly. So you guys can see individually I run this, it is working, right? If I run it again, yes, user should not be empty array when user is created. That is true because I have created one, and I expect the service user db array length to be 1. Okay, we get the expected results. But what will happen if I run the suite? Oh, then there is an error. Should not be empty when user is created. Okay, so here you can see we are expecting 1, but we have received 3. We are expecting 1, but we have received 3. How can be 3? Because we created one single user, and we check the database length, and it's supposed to be 1. Okay, how can it be 3? Any guesses why it is making 3? We just had only one user, right? We just create one user. But when you are running it in isolated mode, that means when we are running only this test method, yes, it is passing. But if you try to run the test suite, it is failing. Any guesses from you guys? Any reasons that you might find? Okay, we are expecting 1, but we are receiving 3. Why it is failing? Any guesses? Anyone? Any ideas? Any wild ideas? I don't mind whether it is correct or wrong. You guys should have an idea. Okay. So the issue is being that when we are executing these prior to executions, we are also creating two users. Okay, you guys can see we create user this one, we create user this one, and when we are creating the third one, we are creating a third user. Okay, so since the service is creating three users, okay, this method executes, this method execute, and the next method execute. So prior to execution, you guys can see these are executing in order. Okay, this this one execute right after the next one. But if you move this to the top, it might not happen, but that is not a solution. Okay, so when we execute the first test case, we get a user. The second test case, it insert another user to the array, and when we insert another user, it it sends to the user once again. So what is the problem here? The database or the array is pre-populated before any of these tests are executed. As I mentioned earlier, when we are writing test cases, the unit tests should be individual from each other. The tests should not affect anything to the other one. Okay, but in here, since we are using the user DB and the user service is only created at once, in the before all function, that means we have one user service instance, and by executing this create method, we are inserting three users. Okay, three users in here. So in the third scenario, our test case fails. Okay, so the thing that we need to do is before each or after each of these execution, we need to clear the state. Okay, we need to clear the state. So I can say before each of these services, user DB should be emptied out. Okay, it should be emptied out. That means before any of the functions, before any of this before any of these uh, tests are executed, user DB, the variable that we hold the array should be emptied out. Okay, by doing that, before each of these execution, DB get reset, and this function or this test case have no effect on this and this. Okay, it's only connected before because the create function is pushing the value to this user DB array. Okay, now if I run this again, I should not have any issues with the ID. Okay, so you guys can see life cycle methods can save a lot of things. Okay, you should use life cycle methods wisely, otherwise uh, it will create a scenario where unit tests will be depending on each other. That is should not be the case. If they are depending on each other, what will happen? The test case are not executing as we expected. And remember one other thing in unit test, that the text execution order should not be even a thing. Okay, if I execute this one and so you guys can see we have a definite order on execution. But if I change this order, if I change, okay, I need this one to be in here and the last one should come up. If I change the order, the execution still should happen. Okay, there should not be a dependency on execution order as well. Okay, but by default it is executing one after another. Even though we are doing that, okay, even though we are doing such a thing, the execution order should not matter on the test cases. Okay, first one is the unit test. They should not be depending on each other, and the test order that should not have an effect on another one as well. So those things keep in mind. Otherwise, it will not work as expected. The test cases might fail. So have a look around the life cycle methods. These life cycle methods will save you a lot of time when we are clearing out and all those things. Have a good idea on those things as well. So overall, we came to a place where we write test cases. Okay. So when we write the test cases, okay, when we write the test cases, did we create the controller? Did we create the controller? No. If you guys pay close attention, in the initiation part, in the before all function, when we initiate the service, we did not care about the controller. Okay. But in real life, when we are executing the application, the controller is the place where we are getting the values. Okay. It is where the REST endpoints is sending us the value. But in the service layer, when we are writing test cases for the service layer, we do not care about the REST layer or the control layer. We do not care about it. We only care about the business logic. Okay. So by separating the application into by separating layers, what we have achieved is we are getting rid of the dependency on the layers that they are interacting with. So whether this function is called from a GraphQL, REST API, gRCP, whatever the underlying function, this function is remaining the same. It does not matter where the data is coming from, as long as there's going to be a user coming into as a parameter and it will be returning a user. This function will be remain working. Okay. By separating, you are not considering anything from other layers. So that is a huge advantage in terms of software testing. And by separating the logic from its source layer will help us to test it better and to maintain it better. So that is the purpose, that is the real use case of tearing out the service layers, control layers, and repository layers. Okay. So without relying on the control itself, we did not even touch the control layer unless we want to see it. Without looking at the control layer, we tested out the business logic. So if somebody comes tomorrow and replace this control layer, the REST layer, with GraphQL